Hello everyone and welcome back at CodingBulls. Today we will continue our competitive programming series and we will take a look into interactive problems. In the last episode I talked about a problem called Nightmare, which was an interactive problem, but I realized that we haven't discussed this topic in the channel yet, so I will show it to you. So, an interactive problem is when your code interacts with the validator or interactor in the background, and it gets the input in different types. So first you get some kind of input, and then you need to ask questions, make moves, or output anything, and based on that you will get other input. So let's just say that you want to guess a number between 1 and 100, and the interactor will tell you if your guess is lower or higher than the actual number, or if you guessed it correctly. So in that case, let's say that the input is between, actually let's be between 1 and n. So you know this, and you get the n in the beginning. So now you know that the answer is between 1 and n, and so first you read this. So let's say that this is your program, and this is the interactor. So the interactor is something that runs in the background and is done by the problem setters. For my problem, I also had to write an interactor. So in the beginning, you just get a simple input. Let's just say that you get an n, number n. Now you need to guess a number between 1 and n, and what the interactor thought about. So there are two kinds of interactors. One of them doesn't depend on your output, and the rest does. Meaning that this program can actually be two different types. Maybe the interactor already decided the answer before you made any output. That's one of the types. And the adaptive type is when it changes based on your questions. So my problem, the nightmare, was adaptive. And some interactive problems are adaptive, some are not. So to see the difference, let's just say that n is here 100. And you ask a number, let's say that you ask the number 40. So this is not the best approach because you would need to ask in the middle. So what happens here is you output 40, and this 40 will come to the interactor. Now the interactor reads your request 40, and there are two types, as I told you before. So if it's an adaptive, then it will see that 40 is not in the middle, and I don't know what the answer is yet, but let's just say that it's above 40, because then there are more options for the participant to look for, and it will be harder for them. So an adaptive interactor always tries to fail your solution. The reason for this is simply because a good solution will never fail, and the tests are there so that solution can't pass. So it will say that, okay, I will say that the answer is higher than 40. But if the interactor was not adaptive, and it already decided that the answer is 30, then it will say that the answer is lower. So this is the main difference, and that's why, if it's possible, adaptive interactors are better to catch bad solutions. And now you know that the answer is between 1 and 40, so let's just say that now you write your code correctly, and now you guessed 20. And oh sorry, so it was higher, so it's between 41 and 100, so let's just say that you guess 70, because it's in the middle. So again, if it was not an adaptive interactor and it already decided that the answer is 40, then it will tell you that it's the correct solution. But let's say it's adaptive. So what the interactor can do is make some contradictory information. So if it already told you that it's higher than 40, then the answer can never go below 40. So it will be between 40 and 100. Actually, this interactor, you don't really need to know, but this is just a fun information, will now store that your possible answer is between 41 and 100. So it knows that it can be only in this range. So now if you choose 70, then it knows that it has to be remain between 40 and 100. Let's say that it says lower, and then it knows that the solution is between 41 and 69. And now you get the input, and then you keep repeating this process until you get the solution. So these lines uses the cout when you output something to the interactor, and you can get the input by simply the cin. So it's the usual standard output, standard input. The only difference is that you need to flash the output after you give some information so the interactor can read it. In C++, it's simply by the flash, so you can go ahead and cout flash like this. If I remember correctly, you can either do this or it's just a flash function. It was the function like this. Let me check. Oh yeah, the cout flash is also correct. Okay. The other way is you output the endline. If you remember our previous videos when I told you the difference between this new line character and the endline is that the endline flashes the output and it's slower. Therefore, in most cases you want to use this if you have to output too many lines. But in interactive problems you have to use the endline or flash the output by the flash command. So if you just need to output lines, it's really comfortable to put endline like this. So you can then get the input and keep doing this process. Hopefully you understand by this, but we will take a look in a practice problem to help you. So once again, you can come to the problem set interactive, and if this is your first interactive problem, you want to set the difficulty lower, and if you are already experienced, you can go ahead and search for something higher. So you can add any text, you can set the difficulty, and you get the list of the problems. So I already chose a problem for you, and in this interactive problem, by the way, it always explains that how you can flash the output or what interactive problems are about, but it's better if you already know, you don't have to worry about it. So in this problem there are m pies of stones, and each pie has stones that weighs 1 gram, but one of the pies have a stone that weighs 2 grams. And what you can do is you can choose k pies, and the interactor will tell you what is the sum of the weights. So it's like if you measure them and you will get the result, and then you have to find out what the solution is. In lots of these interactive problems, if you ask a question, you need to output question mark, then your question, or if you answer, you need to output an exclamation mark with the answer like this. So this is a very usual type. So let's go ahead and solve this problem. It has more test cases. Inside each test case, we have the number and we have the array itself after. So let's go ahead and solve it. Actually, I like to make these global variables because I'm not sure if I want to use them outside of the self function yet. So let's remove this. And now we can just read the input. Now we know how many pies there are, and we know how many stones there are in each pie. So what we need to do is to come up with the questions and find out which pie contains the stone with the weight of 2. So the way it works is because each stone weighs 1, then if we ask a question, and if the sum of the number of stones is equal to the weight that we get, then the stone with the weight 2 is not there, otherwise it is there. So what we will do is we will have a vector of all the possible pies that the stone can be. So we will index them from 0 to n, and the index is from 1 to 1 to n. That means that when we output, we need to output differently. What's a really good trick in most of these interactive problems is to have a function ask that will ask a query and process the results accordingly. Or if you get a single input, maybe you can do long ask, so it will return with the value that the interactor returned for you. And then you will have some parameter here that you want to ask. So let's say that in this case we will have vector longs of pies. So these are the pies that we want to ask. And we will also have a void function let's call it answer, like the answer. And what we will have here is the result of the problem, and we will simply here will output the result, and we don't forget to add exclamation mark like this. This is the format that we need to follow here. Alright, what else? We need to raise the vectors, which is with the clear function, because we have multiple test cases, so we have to erase all the values before we use it again or after we use everything. So we will clear these, we take the input, we push back the possibilities, and here actually I will output reset plus 1 because we index here the possibilities from 0 to n, but we want to output it from 1 to n. We index it from 0 to n minus 1. We want to output it from 1 to n because that's the way it's indexed in the problem statement. And in the ask function, we will simply output question mark, then we will output the pies.size, and then, or we can use the O2, which is easier. So we output a space and then the number, and in the end we will output an end line which flashes the output as well. And then we will have, or we can just call it this as well, or actually let's call it sum, because this is the sum of the weight. And what we will do is, or we will use the auto again, auto as price. What we will do is have the expected sum, and we will calculate it. VS here we have the output as plus 1 because they index from 1 and we index from 0. So it will be like this. So what you can do is, if you want to keep it like this, you can return the sum like this, or you can process its somewhere. So let's say that we will just return, okay, and we will take care of everything else later. So now we have the ask function and the answer function, and in the solve we will create two vectors, possibilities A and possibilities B, and we will somehow divide these into two groups. And actually we will do this while possibilities dot size is greater than 1. So what we want to do, the solution for this problem, given that we know that we can split them into two groups and measure one of the groups, and if it has the same weight as the number of stones, then the bigger stone is in the other group. If it has a higher weight, then it's in that group. So what we basically do is split the possibilities into different parts, and we will know which part is the stone. So we will split them and know the answer, and if there is only one possible pi that can be, then that's the answer. So we will go until the possibilities size is bigger than 1, and when it's 1, then we will use this ans function and answer with possibilities 0 turn, until the possibilities return. And it will run this, and we are done. And what we will do inside here is we have these vectors here, and we will divide these possibilities into two roughly equal parts. So it will be like a binary search. So you can go ahead and cut it in half. You can put the other ones in one, the even in other, anywhere you want. Probably the fastest for me is simply put the evens in PA and the odds in PB. So what we can do is E divided by 2, E1 draw to 0, then we will put it in the PA, push back possibilities I, otherwise we will put it in possibilities. Sorry, we need a question mark here. So otherwise we will put it in PB. You can just come and copy this. You can also make your own condition here. It doesn't have to be the odds or odd or even index. You can do something like if I is greater than n divided by 2, or something like this. I like this. odd even tactic. So what you need to be careful in this is that it's roughly the same size, and these extreme cases when there are only two left, then one of them should be one of the groups and the other should be the other. So what we will do is use the ask function for one of the pies. And by the way, if you don't want to pass these because they make a duplicate for this vector, and it would be faster if simply you pass it by reference, const reference, so you can change the values. So this is slightly faster, but you need to loop through them anyway, so it won't change a lot. So the way it will make it significantly faster is if inside of the ask function you would only use few values of the pies, so you don't need to actually copy everything. So let's say you just want the size and the first element and maybe the last element or something like that, then copying it would be obvious. Here, because we loop through it anyway, it won't change the runtime by that much. But we can just keep it. The difference, it will be slightly faster. So we ask it, and we store the result, and we can actually, instead of storing, we can check if the result that we got is the expected sum. If you want to use the value again, then you have to go ahead and have another variable that you store it, because here you don't actually store the value. And if you call this as function again, it will execute again, and you will use one of your questions. Because if you come here, you can see that you have only 30 questions. We will come back and count how many questions we make a maximum. But if it's the expected sum, then the possibilities vector will be the PA vector. Otherwise, possibilities will be the PB. And actually, let's go ahead and use the question mark operator. So instead of if, we will have the question mark operator, and we can do it on one line of code. Like this. And we need to create the expected sum for the PA vector. So we go to throw to SPA. Expected sum should be plus equal to VS, because this vector contains how many stones there are in each file. And one more thing we need to check if it's allowed to have 0 stones in a file, but it's likely not, because then it wouldn't even be a possibility. And now we can estimate the maximum number of operations. So we have 2 times 10 to the power 5 of maximum pies. Every time we cut the possibilities in half. If it's odd, then we can assume that we get the worst result, which will be the larger one. So it will be the logarithm of it, and actually the upper bound of the logarithm. So if it's the logarithm will be like not an integer number, but we will have the maximum number of questions of the ceiling of it, so the number that's higher than it and an integer. So for 2 times 10 to the power of 5, that will be 200,000, and which will be, I think, even less than 20. So it's, yeah, because 2 to the power of 20 will be around 1 million, so it's even less than 20, maybe 17 or 18. So we are inside of the 30 limit. So in interactive problems, if you want to test it, you can go ahead and run it, but you most likely have to come up with your own input. So let's say that n is 10. Oh, this is the test cases, sorry. So 10 test cases and it's 10. And then we will input the array. Let's say that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now we ask 5 of these. So let's say that the sum of these should be 1 plus 3, that's 4, that's 9, 9 plus 7, 16, plus 9, it's 25. So it should be 25. Let's say that we said it's 25. So as you can see, it keeps asking between these numbers. So 1, 5, 9. Let's say, so the sum of these should be 1 plus 5, that's 6, plus 9, that's 15. So let's say that we say it's 16. So the stone, oh actually, I made a mistake because we should do it the other way around. So if the sum is the same, then the stone is on the other part. Otherwise, it's the same part here. And now, if we just copy and paste this input, it won't be the same questions that we ask. So that's why we can't really use the example input. So we either need to come up with our own, or you need to test your code and submit it blindly. If you remember, if you get wrong answer on the first test case, it doesn't matter. So I'll just say that we have 2 test cases and let's have only 6 or 8 pies now, and the sum values will be like this. So it has 4, 4, and the sum of these will be 16. So let's say it's 16. So it knows that it's in the other part. So now it has for the 2 and 6. Let's say that it should be 8. So let's say it's 9. That means that the stone is there, with the weight of 2. Now it has the 2. Let's say that the sum is 2. That means that it should be on the other. So meaning that the answer is 6. And now it tests as the answer is 6. Let's have one more test case. Let's say that there is only one pile with the weight of 100, but it doesn't matter because it will be there. We don't even ask questions. So now we can go ahead and submit it. And I'm going to source the file, submit it, and we can see if it's correct or not. And it's accepted. Should accept it. It's done, yeah. If you get something idleness limit exceeded, that's probably in interactive problems, that's probably because you still try to interact with the interactor even though you got a wrong answer verdict. So if you just keep asking values after you are not allowed to, then you can get this verdict. So this was an interactive problem. Hopefully you understood it and you liked today's video. If you did, make sure to like and subscribe, and see you in the next video.